Hello guys, welcome back for fourth video for unit number 5 under our Metrology and Quality Control. So last video we discussed about control charts for variables, particularly X bar and R chart. How to solve also be discussed, and one numerical we have discussed. So maybe you can understand this numerical we have solved and how to refer this factors for contributing variable control charts also we have discussed. So what are all the parameters read? A2, A3, you need a D3 and D4, okay, and sometimes you need a D2 also. Then observation samples like sample numbers you need to check. So with reference to the sample number, either A2, A3, chart for average means chart for average or chart for mean means X bar, chart for ranges means R chart, and standard deviation also you can refer from here. Based on the sample size we can able to check. And marker, okay. Then this numerical example we have discussed about diameter, since variable charts in the sense continuous, and it is possible to measure and say. So 25.75 plus or minus 0.1 millimeter will be can be measurable, right? Using some vernier calipers, we can able to measure the diameter of the shaft. So every hour they collected every hour they collected 6 data continuously and reported the dimensions and construct the X bar and R chart we have discussed in the last video. First, we have to calculate X double bar. For calculating the X double bar, you have to calculate first summation of X, X1, X2, X3, X4, X5, X6, summation of X. Then X bar we can able to calculate. So summation of X is 154.59. Then divided by 6 because 6 number of samples. So you will be getting 25.765450. Similarly, for first hour to 8th hour, you have to calculate. This is X bar. So once you need, if you got X bar, then you have to calculate the X double bar. That X double bar will be your center limit CL in your control chart. So that can be estimated by this summation X bar. This is X bar, summation of X bar. For example, all summation 25.7650 plus 25.7700 up to here by summing up and divided by 8 because 8 hour every hour, so 8 hour data we have, so totally 8 samples and subgroups. This is 8 subgroups, this is samples under one group. So total you can able to get the X double bar. Once you have X double bar, you can able to calculate the lower control limit and upper control limit using this formula like X double bar minus A2 R bar, and for upper control limit X double bar plus A2 R bar. A2 can be referred from the table, and you have number of samples 6, subgroups only 8, subgroups 1, 2, 3, 4, 5, 6, 7, 8 is subgroup, but sample size 6. So with the sample size 6, we can able to estimate what is A2, or not estimate, we can refer the table and A2 value we can put it here. But we need to calculate the R bar. R means range. So if you want to calculate the range, first of all you should know what is maximum, what is minimum. So that is what estimated in this table, maximum, minimum. Maximum from this 25.8, minimum from this 25.73. With this difference, X max minus X minimum, you will be getting like a R. So this is R only, not R bar. So once you have R, summing up of all, then you can able to get R bar. So summation of R divided by N, you will be getting R bar. So once you know the R bar, again you can calculate LCL and UCL, and you can able to draw the control chart with the central value, central level, and upper control limit and lower control limit. All the plots you can able to draw. Okay, so this is your X bar things. So the plotting in control chart plotting, you given 8 points. What are all the points? X bar point 25.7650, 25.770, 25.7717. These values only plotted in this graph with reference to the center limit which is calculated by summation of x bar divided by n. Then you have to do R chart. For R chart, you need again three values: center limit R bar, lower control limit D3 into R bar, upper control limit D4 into R bar. R bar, you know, summation of R divided by N. R can be calculated based on maximum to minus minimum. Then D3 can be D3 and D4 can be referred from the table. Substitute that, and you can able to do this R. Okay. So for range also, from the table, these values 0.07, 0.11 like that. These points you can put it, plot it over here, and all the points within the limit, so we can accept this process and it is under control. Followed by this video will be discussing about example number 2 and 3. So in this example, the control charts for X bar and R are maintained on certain dimensions of a manufactured part measured in millimeters. So measured in millimeters, sometimes it's not given R bar or a X bar chart. If measured variables, measured value continuous like that, it is given, you have to assume. Then subgroup size is 4. Okay. Subgroup size. So subgroup, we don't know how many number of subgroup, but one subgroup having a size 4. So sample may be 4. Subgroup size is 4. Values of X bar and R are computed for each subgroup. For each subgroup, they calculate R bar, X bar and R. After 20 subgroups, summation of X bar, they given directly, they given instead of giving data points, directly they given the X summation of X bar data and summation of R bar data. So once you have summation of X bar, once you have the summation of R, you can able to calculate the X double bar or R bar. So compute the values. Compute the values 3 sigma limits for the X bar and R chart and estimate the values of sigma pi means standard deviation. This symbol sigma pi if it is given or sigma dash if they are given, it is called standard deviation on the assumption that process is in statistical control. By assuming that it is under control. So what are the things you have to calculate is, since they already given summation of X bar, you have to calculate X double bar. So this is the method to calculate X double bar, you know, summation of X bar divided by N. So here N is total number of subgroups 20. Sample size is 4 because subgroup size is 4 means sample size from each subgroup they taken 4, but total number of subgroup is 20. So total n divides, if you divide, then x double bar you can able to get. So x double bar you got, and the summation of r also given. So you can able to calculate r bar also, summation of r divided by n 20, you will be getting some values like 0.169. Here x double bar 20.6415. Then compute the values 3 sigma limits for this and also estimate the values for sigma dash. So sigma dash, this formula you should remember. Sigma dash, what is the sigma dash means? Population standard deviation. It is representing whole population. It's not sample standard deviation, it's a population standard deviation. So population standard deviation can be estimated using R bar divided by D2, small d2, small d2. So this R bar you calculated here, but D2 can be referred from the table. So referred from the table in the sense, where is the table? Okay. This is the table where is D2, small d2, d2. And it should be referred here, but based on what? Based on the sample size, 4 sample. In each subgroup, you have sample size is subgroup size is 4. So 4 and D2 2.059. 2.059 is D2 value. So you will be substituting that D2 value. Yes, 2.059. R bar also estimated. So you can able to get the sigma dash, that is population standard deviation, 0.082. So once you have the sigma dash sigma prime, you can able to estimate the 3 sigma limits. This is the 3 sigma x bar. So 3 sigma x bar equal to 3 times the sigma prime divided by square root of n, small n. Small n in the sense sample size. Here subgroup size, here sample size. Sample size is 4. If you substitute, you can able to get value of 3 sigma limits. Okay. So now you have this value also. So x bar we know, r bar we know, population standard deviation we know, and 3 sigma limits for the x bar also we calculated. Then for x bar chart and r chart, you can able to calculate the upper control limit and lower control limit. For upper control limit, we can have this equation x double bar plus 3 summation of x, sorry, 3 sigma x bar and x double bar minus 3 sigma x bar. So this one we calculated from the previous page. Already we know this x double bar. Substituting that, you can able to calculate the upper control limit and lower control limit for x double bar chart. Similarly, r bar chart we can able to calculate easily. R bar value we know, D4 and D3 we can refer from the table with the subgroup size of 4. 4, if you calculate the 2.28 from the table, so let's see, D3 and D4, sample D3 and D4, 4, 0 and 2.282. So D3 is 0, D4 is 2.282. D2 and D4 is 0 and D3 is 0. Sorry, D4 is 2.28 from the table and D3 is 0. So upper control limit, lower control limit we can able to get. Then directly we can able to draw some plot and because we have the x double bar value, we have D3, but data points we don't know. Since we don't have each data points, we can't able to draw. But only thing you can draw like XY axis and upper control limit, lower control limit, and central limit value. Okay, you can't draw data points because directly they have given summation of x bar and summation of r. So this is the example number 2. So in this one, what are the things new? You should remember how to calculate population standard deviation. So population standard deviation, if you want to calculate, it can be calculated based on this one. Population standard deviation represented sigma dash or sigma prime r bar divided by d2 or summation of r and divided by n, we can able to get the r bar. So r bar divided by d2, small d2, this d2 can be referred from the table. Then if you calculated the population standard deviation, then you can able to estimate the 3 sigma limits, that is for x bar 3 into sigma x bar equal to 3 times the sigma prime divided by square root of small n. This small n represent your subgroup size, not number of subgroup size, that is n equal to 4, you can able to calculate. So once you have this 3 sigma x bar, we can able to calculate upper control limit and lower control limit for your x bar chart, and also with the D4 and D3 value from the table, we can able to get the upper control limit, lower control limit for your R chart. Okay, this is the example number 2. Example number 3, it is also similar like example number 1. There is a small difference from the example number 1. That's why I given here. Remember, it's very important one. So in a capability study of a lathe used in turning a shaft to diameter of 23.75 plus or minus 0.1 millimeter. So the purpose of lathe machine for turning a shaft with a dimension of 23.75 plus or minus 0.1 millimeter you have to make. This is the requirement. A sample of 6 consecutive pieces, 6 pieces taken for each day for 8 days. Okay, not every hour, every day they are taking, not every one day, every hour. Here, every day, one time we are taking, and one time if they are collecting some sample in the sense 6 pieces they are collecting, and also the dimensions they are measuring using some measuring instrument, and the values are tabulated here. The diameter of these shafts are given below. First day, second day, third, fourth, up to eighth day data. It is given here. What they are asking: construct the X bar and R chart and find out the process capability for this machine. So this one X bar and R chart also, and also along with that they're asking to calculate the process capability for the machine. So how to do? So as usual, if you want a X bar chart, R chart, you have to calculate X double bar, R bar. So in order to calculate the X double bar, you should have a summation of X bar divided by N, capital N. So summation of X bar in the sense, you need to calculate the first X bar value, x1 bar, x bar, x2 bar, x3 bar up to 8 days means 8 data. So x1 to x6 because 6 samples taken in a day. So 6 divided by 6, sorry 6 data plus you have to add divided by 6, you will be getting x1 bar. Similarly, you will be getting what to say, you will be getting each data x1 bar to x8 bar, you got all the data. So totally you have 8 data. From here we can able to easily calculate the x double bar. So summation of all these 8 divided by n, totally 8 days, subgroups are 8, so substitute that, you can able to get the x double bar. So this is x double bar. Then similarly, from here first day maximum value, minimum value, then difference between maximum to minimum will be the range R value. Similarly for second day, third day, fourth day, eighth day, you can able to calculate. Once you calculate the range R value, once you calculate the R value, R1, R2, R2, R7, R8, you can able to calculate the R bar. R bar is summation of R divided by total number of subgroups, N, capital N. So all summation of 0.07 to 0.07 divided by N8, you will be getting R bar. So now you have a X double bar, you have a R bar. What else you need? You need upper control limit and lower control limit. You know the equations or formula. So, so instead of 3 sigma X, 3 sigma X bar, now they are using X double bar plus A2. So A2 value need to refer from the table. From the table for the sample size, how many number of samples? 6. So for 6, A2, where is the A2? Okay, A2 and 6, A2 here because chart for average, and sample number 6, then 0.483 is the value. So once you know the A2 value, substitute the A2 value, R bar value you calculated, you can able to get the upper control limit for X bar and lower control limit for the X bar chart. So two values we can. So A2 value from the table. So 0.482, it is assumed like 0.48. So if you substitute 0.482, maybe the decimals may change. So try. Then R chart, upper control limit, lower control limit, D4 R bar, D3 R bar. So up to sample size 6 or less, D3 is 0, only D4 value. For D4 there is a value 0.0675 from the table, sorry 2 I think, and R bar value we calculated from the previous step 0.675. So D4 value is to substitute that, you will be getting the upper control limit for R. So all values you know, you can able to draw some chart. It's one. But they asked for process capability. Okay, so they checked in this particular problem. They asked for process capability, something different. So what is that? How to calculate? So in order to find the process capability, you need to first calculate six times the population standard deviation. It's not standard deviation. Six times the population deviation means six times in the sense mm, uh, from the center line, 3 sigma above, 3 sigma below generally will be considered, right? Within that range, we can consider process under the control. So above 6, above 3, below 3, or put together 6. So 6 standard deviation, population standard deviation will give you some value. That value, if you calculate with the range of the data, if it is greater or lesser, we can able to identify whether the process under control or not. So 6 times the population standard deviation. This is sigma prime or sigma dash. You should remember already in second problem we discussed for sigma prime r bar divided by small d2. This d2 you can refer from the table. Subgroup size is 6 and d2 value 2.53. Substituting here with the r bar value, you will be ending with 0.1592. So this, whether this value is greater or lesser than your range value. Range value in the sense x max minus x minimum. X max minus x minimum. So it is given 0.2 millimeter from data. So where they calculated. So in order to calculate the range, generally you get for each subgroup, you will be having x max, x minimum. Then you can find the difference. But here from the data, original data in the sense, what is the original dimension they given? What is the original dimension they given? 23.75 plus or minus 0.1. So this is maximum and minimum. That limit, what is that range you can maintain? Because you should not take it the range, which one you don't know. First day data, second day data, third day data. Sometimes people might think overall maximum, overall minimum. No. What is the expected dimension? It is required from the production 23.75 plus or minus 0.1 in the sense either 23.85 because 0.1 is there, either 23.85 or 23.65. So either 23.85, 23.65 in the sense what is that maximum to minimum difference? 0.2 millimeter. 0.2 millimeter is the difference for you, right? So 0.2 millimeter is the difference. So from the original data which is given or expected from the production. So original dimension needed set. So with that 0.2. So this is the expected one. What you calculated from the process capability with the ranges and the data D2 0.15982 millimeter. So comparatively what you are required is greater than what you are achieving. So we can conclude that all manufactured products will meet specification as long as the process stay in control. So it's under that what calculation you done. This is because this calculation means what? This R bar calculated by the data which is achieved from each day's range data. So all this comes under the below your 0.2. If this value is greater, this is lesser, then it is not under control maybe. So you have to check or do some changes. But now process under control. So process capability you identified or you calculated from this example number 2. Okay, so now, sorry, example number 3. So now already you have checked about 3 examples for X bar R chart. Fourth example, I'm not going to explain in detail. So they have given data. The quality control inspector at the Coke company or soft drink company has taken 25 samples. So they have taken 25 sample for with 4 observation 1, 2, 3, 4. Maybe we can say subgroup 4, but sample size is 25. Each volume of bottle filled, the data and the computed means are shown. So all the data given X bar and R. If it is not given, you can easily calculate X bar or R value. So once you know the X bar and R, you know how to calculate the X double bar and R bar data. Then 3 sigma X double bar plus 3 sigma X bar. Sigma X bar you can able to calculate from this equation, with the standard deviation divided by total number, like a subgroup 4. If you calculate, you can able to get the upper control limit, lower control limit. In another way also they calculated X double bar and R bar, and with A2, with A2 value. Similarly for R bar also they can able to calculate with D3 and D4. So just for understanding, just I added, you can able to calculate some values for understanding, better understanding. So up to here, I am stopping for X bar and R chart examples. Okay. So practice, do practice and refer that. I have uploaded the textbook also. You can refer some other problems and get a better understand. Okay. So I'm closing this video. Next video, we'll see some introduction about P chart, NP chart, and C chart and U chart. Not big numericals, just formulas. Maybe for P chart, some numericals. Then next video will wind up. Okay. So I'm closing this video. We'll see you in the next video. Thank you.